Okay, welcome to this introductory video to Chapter 4, and this will cover the material in 4.1, which is pages 134 to 146. So that's several different sections of homework that we're going to look at, A, B, C, D, and so forth, or problems. The videos are your homework, the problems we'll do in class. This material covers all of it, and it's just a slightly different way to look at it. I want you to read the book as well, read all those pages in 4.1 as well, and I'll try and give you some more to go on here. We're talking in Chapter 4 about mathematical models, and one of the concepts that goes all the way through it, it's very important to understand because it sort of pulls a lot of things together, is the concept of a function. So that's where we start in Chapter 4. Before we can even talk about a function, I think it's probably useful to go through a concept the book doesn't mention, which is a relation. So that's what we're going to talk about first. A relation can be described in any one of several different ways here. And the basic idea is a relation is any set of ordered pairs or a mapping from one set into another. You can express a relation as an equation where the things you put in are one set and the things you get out are another set. And finally, you can look at a relation in graphical terms, in terms of the x and y values of those elements, and then numerically putting them into the coordinated plane. Now, what we're going to talk about is that's a relation. Any set of ordered pairs is a relation. Any graph you could draw is a relation. Any equation that you write out that has an x and a y in it could be a relation, and any mapping from one set to another. So a function is a particular kind of relation. A function has characteristics that not every relation has. It's a special kind of function. So I want to go through each of these and then we'll look at how you spot a function. Okay, so a function is a relation where you have sets of ordered pairs and there's no repeated first elements, no repeats in first elements. So whatever comes first in the relation, there's only one of them. They're not two different ordered pairs that start with the same element. So if there's an ordered pair that starts with 2, none of the other ones have 2 in it. Okay, it's a mapping. It's a particular kind of mapping. It's a mapping where every element in the set you start with is only mapped to one other thing. So each element is mapped to only one other element. Now you could think of other relations, right? Where an element might be mapped to 2 or 3 or 100 different elements. And in fact, there's nothing preventing 2 different elements from being mapped to the same one. That's okay. It's just that each element that you start with, that comes first in the ordered pairs or that you start with in the mapping, has only one other thing it's mapped to. Now when it gets to be an equation, there's an easy way to spot a functional equation, and that's functional notation. And we're going to talk about that on page, functional notations on page 144. Okay? So it usually uses this f and then parentheses and x, f of x. Another way to say it is that you could solve for y. Okay? So any equation is a relation. An equation in which you can solve for y or put it in functional notation, that's a function. Now what about a graph? If you draw a graph of a function, it has an easy to spot characteristic that every vertical line either hits the graph once or not at all. So we'll say it's the vertical line test. All right? Any vertical line either hits it once or not at all. Hits the graph once or not at all. So by the thinking of that way, if you find a vertical line that goes through the graph more than one time, then that's not the graph of a function. It failed the vertical line test. The graph of a function is such that if you imagine a vertical line moving through it, it only hits it one time, or it doesn't hit it at all. So a function is a particular kind of relation. Now, I want to look at how the book goes through these same concepts. So let's move over here and look at what the book says on the subject. I'm going to zoom out just a little bit because I'm going to be able to make that bigger. Well, let's leave it big. There. Okay. So this is the very beginning of 4.1. And this is on page 130 134. And here's the definition. A function is a relationship between two sets. Well, so is a relation, right? A relation is a relationship between two sets. But a function is a particular relationship. The first set and the second set, we're going to come to the names of those. But each element of the first set is related to one and only one element of the second. All right, now that's important because they want to make sure that everything in the domain has something it's related to. And I went ahead and called it the domain. We're going to get to that language in a little bit. Let's look at some examples. Now that's the definition of a function that I gave in the mapping. So the first thing they look at is a mapping. Now here's a mapping drawn out in picture form. In fact, let me zoom in a little bit more. Okay. Now we have two sets here. This set A contains three elements, Antonio, Lola, and Mu. B contains two elements, GVS and JHS, and the mapping is the arrows connecting them. This is a functional mapping. Every element in the left-hand side of the first thing, where the arrows begin, is only mapped to one other thing. Now if we take this whole mapping and reverse it, then you get the second one. Okay, it's the same sets and actually the same arrows, just with the arrowheads on the other end. This is not a function, because this element is mapped to two other things. So that fails the definition of a function. A function has every element only mapped to one other thing. Okay, now that is the example one, and it's on page 134. All right, now let's talk about a little bit in terms of the vocabulary of what they're talking about, some of the terms that they're using, and we'll get them straight, and I'll give you some page numbers for those as well. So let's shift back to the whiteboard. Okay. We're going to talk about some notation and some terminology, okay? So the one thing we want to make sure is we understand our domain and range. Domain and range. Okay, so these are two sets. The domain is where the arrows start, and the range is where they go. So the elements that you have on the left-hand side of all your ordered pairs, the inputs to the function, and the x values of your graph, those are the domain. So we generally, and from the very beginning in the book, think of the domain as the x values, okay? The things you're putting in. The range is what you get out, what they're mapped to. So those are the y values, okay? Now, when you have an equation, and you don't always, sometimes you could have an example like that one we just did with people's names and schools. There's no equation uniting them together. But in our numeric examples, we will. Well, then, what you're going to have is, that leads directly to a graph. You can make your ordered pairs with x's and y's, and the x's are numbers and the y's are numbers. When that's the case, we say that x is put into the function and y is the output. So this will be the input. This will be the output. Okay? Now, there's some language we use a lot, and it's actually incorporated into the graphing calculator as well, that also says the domain, the x values, are the independent variable. The independent variable. And then y is the dependent variable. So, what that means is that y in our function takes its value from x. It's not independent. We define the y values in terms of that function. So in general, we would have x here, and maybe y would be f of x. Okay? So when we set up an equation and we have that format where you have f of x equals and then an expression in x, it's guaranteed to be a function, as long as every value you put in for x allows you to only calculate one y value, which typically they do. So, you know, if your equation has x's and y's all mixed together and you can't algebraically separate them, that probably isn't a function. Okay, this terminology of domain and range and independent variable, all page 137. So let me change the textbook. We'll move up to 137 and we'll take a look. All right, there's 135. Here's 137. Okay, take a look at page 137. And there you have it. Domain and range of a function. And they say some of the same things I just did. That the first set's the domain, the x values, the independent variables. The y values are dependent and things like that. And they use this other language here, the image. The image. So another thing to keep track of with regard to functional notation is that f of x is the image of x under function f. Okay? We have a function. It maps x's to y's. F of x is determined to be the dependent variable that goes with the independent variable of x. So those are all terminology we use in functions. So domain, range, image, left values, right values, the starting set, the ending set, those are all the things we have involved in the beginnings of the terminology of functions. Now, that'll carry us through quite a ways, and then we're going to start in the next video to look at specific examples from the problem sets. So let's stop there and we'll go on and look at next some problems from A, B, C, and so forth.